anytime you have any questions, please just, shout them out and everything, and we'll discuss them. Hopefully everybody has a question, and that's why you're here today. The world is changing rapidly, and to meet all sorts of different criteria, such as clean air, emissions, fuel economy, safety, there's rapid changes in the automobiles today. Years ago, a car broke down, it was no big deal. You could usually get it running one way or another, and everybody knew what components were on a car. Today, you lift the car, the hood of the car, you have no idea at all what is underneath the hood of the car. You need a lot of sophisticated diagnostic machinery to work on it. That doesn't mean that the technicians in the future are going to need less training. If anything, it means more training. You're going to have to get back to more of the basics of using meters, back to some math. The manuals are written by people who design the vehicles, and they show the manuals to each other, and everybody up there is comfortable. By the time it filters down to the people in the real world, it's a little complex, a little complicated. Also, between manufacturers, although the systems may be very similar, everybody likes to play name games with regarding the systems on the cars and the components. There's a little sensor that goes in the exhaust that measures the amount of oxygen. Does anybody know what that's called? Okay. That's a GM term, right? O2. Anybody know what Ford calls it? They call it a HEGO, heated exhaust gas oxygen sensor. So, and then you go up to parts. Has anybody worked in a dealership or had any experience with a dealership? You go up to the parts department and you tell them what the shop manual calls it, and they look at you like you're from Space City. So communications are a real challenge and a real problem. As far as the, how many people in here are familiar with the computer-controlled engines? One, two. Somewhat. Some people shy. Why don't we take? Who's got good handwriting? Anybody have what they feel is good handwriting? Everybody keeps pointing at everybody else. And can I believe you? You got an honest face. Do you really have? No? Nobody claims to have good handwriting. We'll have to choose someone. Who has legible handwriting? Anybody in the front row got legible handwriting? You guys know to be able to sign checks, I guess. Okay, you got it. Why don't you step up to the board? We're going to design a system. Let's say everybody in here was charged with the responsibility of designing a computer-controlled system on a car. You can give me a piece of chalk there. Okay, what would you want to do? You guys are designing the system, you folks, excuse me. What would you want to enter into it? We're on a roll. Anything. How would you design the computer-controlled fuel system? Okay, we got to have something to do it. So let's draw a little picture of an injector, okay? Injector? Yeah. Do it small. Okay. Okay, we got an injector. What else do we need? The injector's going to do what? It's going to inject fuel. Okay. I'm impressed. You're not a farmer, too, are you? And that's normally a farmer term. Okay. So we're going to inject some fuel. What else are we going to do? What else are we going to need? We're going to just turn it on and inject it forever?
One line.
Pardon me?
One fuel line.
Okay, we've got to run some fuel lines to an electric pump back to the tank, okay? That's why you were picked for this high-paying job.
Tank.
Okay, there's a tank. Fuel line, let's put an electric fuel pump in the tank. Okay. Ford does something with their electric fuel pumps. Anybody know what?
They put a cutoff switch in the trunk. If you get hit or
Right.
something, it automatically shuts off.
Exactly right. Have you had experience with it?
Many.
Okay, first-hand experience. It's also a good anti-theft device. You just bang it, it pops, nobody can rip it off. Okay. So, we're on a roll. We've got fuel, we've got a pump, we've got injectors. That's all we need. What else? Does anybody want? Okay, throw a little box for a computer. What's the computer gonna do? Okay. Computer is probably the dumbest thing in the world, because it only knows what? 0 and 1. That's all it knows. That's the only thing it knows, and it only knows to do what it's told to do. So we got inputs and outputs. Now we're really on a roll. Okay, what inputs are we going to use? What's going to determine if we're going to run hot or cold?
Load.
Okay, load. So how are you going to measure load? What's going to determine the amount of load on a vehicle?
Engine vacuum.
Okay. All right, engine vacuum. Let's put a, what sensor do you want to call that? All right, we'll call it a map sensor. Throw another little box. Put MAP in there. Okay. That's going to tell us whether we're in Death Valley or the Rocky Mountains, right? And it's going to enter engine vacuum. And that's going to tell us where we are in regard to engine load. Is there something else that'll tell us about engine load? What's the little thing on the right hand, the pedal on the right on the floor? Somebody from the back. All right? Gas pedal, okay? What's that going to measure? What's that going to do when we step on it? All right? Well, it's not really going to give us fuel initially, is it? That's going to tell us where we are throttle-wise. So we want another little thing called the throttle position sensor, and that's going to tell us whether we're at idle, hard throttle, or open throttle. So we'll call that a TP. Okay. So far, we're going to know what engine load we've got, whether we're in Death Valley, whether we're in the Rocky Mountains, where we are throttle position-wise. Anything else you want to measure? When you start the car in the morning, what usually happens? Choke. Okay, we've got to put a choke on it. Now, anybody know how our injectors work? Mechanically, electrically, or what? Right, these are going to work electrically, and we're going to make it rich by how? Anybody got any idea? We can only inject so much fuel, so to inject at one time, so to inject more fuel, we're going to keep the injector on what? Longer, okay? So we're going to, when would we want the injector on longer to inject more fuel? When we're stepping on the accelerator. Another time is when? Climbing a hill. What about when you go out in the morning and start it? Okay, we're going to want it on. But how are we going to know whether we're starting it in the morning or whether we're starting it in the afternoon? Temperature. So let's put a little sensor in there called ECT, engine coolant temperature sensor. See a bright future for you folks in the design world. You guys are really rolling. That's going to tell us if it's hot or cold. All right? There's another thing we want to measure also, other than the engine coolant temperature sensor. Anything?
Oil pressure.
Pardon me?
Oil pressure.
Yeah, we want oil pressure, because if we don't have oil pressure, what? We don't want to run. Right? You want to put a little oil center there? And we also want to know the temperature of the air, right? Later we'll believe we have densities. You want to put one more called ACT. So we're going to take all of those, we're going to feed them in to the computer, to the program that we ran, and that's going to determine the amount of fuel that's delivered. But what else do we do when we want to, what are we going to do for an ignition system? Don't everybody holler at once, or we're going to definitely have the full stroke. Any ideas, any thoughts? About the back row. Guys, stand up, it's your turn. They've been carrying it so far. We only had one young lady answer the most difficult question of the day. Everything. What do you want to do for a distributor on this? Forget it or what? Yeah, it's getting to the stage in the training and technical world where when you bring up points and condensers, some people are questioning points and condensers. What are we talking about? In another couple of years, it's going to be, has anybody ever seen a carburetor? It's everywhere. All right, we'll put a distributor in. How do you, what's going to replace the points and condenser in the distributor? Module. Or is somebody down in Georgia who calls them modules? And that's going to replace it. And what's going to control that? The computer's going to control it. So what we've effectively done is we're going to control our fuel injectors based on a whole series of things. We're going to control them based on what? Timing. Based on, young lady, it's your turn again. Based on what? Just say what you said before. Right? Position of the gas pedal. What else? Where is it? Somebody just, you said it. What did you say last time? Vacuum, engine mode. That's going to determine where we stand, how much fuel we inject into the engine, and at what point in time. So you've got all these electronic controls. What is usually the most reliable, would you think, that needs replacing least? Exactly right. The computer.
All right. I'd like to welcome you all here today to the second annual Automotive Careers Workshop. The idea of today's presentation is not to sell you on a program. I don't know what the other particular programs are offering at this point as far as what they're telling you. The idea today is to challenge you, all right? Regardless if you take the CAP program, the Chrysler Dealer Apprenticeship Program, which I hope you do, okay? If you take the CAPS program, that's great. But if you choose Ford, or you choose GM, or you choose one of the other manufacturer-sponsored programs, so be it. What I'm putting to you today is I'm putting a challenge out. Challenge yourselves. This industry is an extremely rewarding, profitable industry. It's not easy. It's not the days of set at 30 degrees well, pull the vacuum advance off, set the distributor at 8 degrees and tighten it down and go. If it pings a little, you back the timing off a hair. It doesn't work that way anymore. Anyone know how you set the timing up on this dual overhead cam, port fuel injected, intercooled turbo? Yeah, let me think. Hold on, let me double check that. No Mr. Spock's in the audience? What's that? If you take this to most gas stations, they'll scratch their head. This engine's 2 liters. It's 121, excuse me. I've got 2 on my mind. 121 cubic inches. It makes 190 horsepower. It's intercooled, turbocharged, all-wheel drive. 65% of your power goes to the front wheels, 35% to the rear wheels. Straight as an arrow. This thing winds up to 8,000 RPMs faster than you can snap your fingers. And it holds up, last I checked. What I'm saying is, this engine has no distributor. It's a distributorless DIS ignition, often referred to as direct ignition system. No distributor, no means of setting your timing. So if you take that in and say, I want the timing check, it's pinging, if somebody doesn't know, they're really going to chase their tail and you can have a good laugh. All right? Here's a DIS ignition module off of actually it's off of a 1990 V6 that Chrysler introduced in 1990, a 3.3 liter engine. 1991, they took this engine and punched it out a little bit and made it a 3.8 liter. Distributorless ignition. 3 coils, fire 2 cylinders at once. One's on compression, one's on exhaust. But how does a computer know where that particular cylinder is? How does it know if it should fire coil 1, 2, or 3? Or for that matter, how does it know to fire injectors? 2 and 4, 5 and 3, and what's the last? 2 and 6. Okay, very good. Has a sensor like this one. This is the cam sensor. Believe it or not, it's a magnetic tip. It's what we call a Hall effects. On the cam gear is a series of notches. Little blips, so to speak. As the notches pass by this tip, it's going to give a little break in the circuit, and a computer can count it. Regardless how fast you make it go, the computer can count it. When it starts seeing a series of blips, and then it sees a long series of blips, or actually in this one it sees a triple blip, it knows that's where number 1 cylinder is. So it automatically records that that's where number 1 is. Now as far as how fast the engine is running, there's a very similar sensor to that one mounted over the flywheel in the back. The flywheel is notched, and it gives an RPM input to the computer. The computer knows, knows where number 1 cylinder is, and it knows how fast the engine's running. Also through a throttle position sensor, it knows how fast you have your foot in it, or know how far you have your foot in it. There's coolant sensor, it tells it the temperature. There's manifold absolute pressure sensor on board, it tells it what kind of a load that engine is under. From that, it determines your air-fuel ratio and your spark curve. How much advance can you put into it? And the amount of advance is the standard of your mind. They can run very lean, very high timing, they get excellent fuel economy, and they've got a lot of power and very clean exhaust emissions. We've met that intersection finally of clean exhaust, good fuel mileage, and performance. All because of electronics. All right. There's a distributor right here that is off of the 3-liter engine, which matches up with this manifold right here, which is a port fuel injected V6 60-degree engine. Distributor here, this is not a distributorless ignition, but it's very close to it. I'll pass this distributor around. What you're going to notice is there's a little laser disc in here. It's a laser cut disc. There's a little light beam in here that's going to shine through a light emitting diode. Every time the trigger wheel comes around and breaks that light beam, it trips it in it. I'm already stumbling, Joe, and it's only the second period. It trips a transistor on and off. That transistor popping on and off tells the computer how fast the engine's running from the 6 individual slots internally, and then there's 360 slots around the perimeter with a gap in between. When the computer sees that gap, it knows that's where number 1 cylinder is. That right there triggers the coil on and off, and also knows what injectors to fire. Anybody ever heard of the Malware Unilight system? Performance Unilight? Very similar to this. Uses a light beam and a trigger wheel. All right, questions or comments? What I'm getting at today is that technology is here. It's only going to go further. It's not going backwards. It seems very complicated. I mean, DIS, you look at this engine right here, oh, wow. It's not that complicated. Okay, you have a distributorless coil setup. You know you have a pickup for your RPMs. You have a pickup for your number 1 cylinder position. If you're not getting ignition for some reason, it's easy enough to track down. There are some very simple tricks that will tell you where to go. One thing that Chrysler has done is they've gone to great lengths to produce diagnostic manuals, drivability books. This one here happens to be 1990 powertrain for the Dodge 50 with the 3-liter. Dodge 50 is a little Ram pickup, and it's with this V6 3-liter engine in it. This just has to be one of the books I grabbed. Okay, includes no start drivability. These books have been designed, they give you illustrations, and also they give you a complete breakdown in a flow chart, step by step, of what you should be doing to find that problem. This one I just pulled here happens to be injector testing, testing the injector circuits for code 41. It's a fault code, a hard code, a problem within the system that the computer has recognized. This is a drivability test. If I went down earlier on in a manual, I would have visual inspection and then no start test. Vehicle comes in on the rack, up on a flatbed or what have you, does not start. Okay, let's get to the book and find it. They start simple and work their way down. If there are no codes inside, then you really have to go through with a no-fault type of drivability diagnosis. The books are excellent for that. They have gone to great lengths to do this. It helps. I mean, even if you're an hourly employee, you're not flat rate or whatever, it helps. It gives you direction. The nice thing about the program that we have up at college is we are backed totally by Chrysler. Everything that goes to a dealership comes to us. All the specialty tools. You go into the backside of a dealership and you have all the specialty tools. They're blue and white plastic sheets on a wall with all the tools. We get them all. Chrysler, Plymouth, Dodge, and Jeep Eagle. I have enough tools back there, it staggers me. All the specialty tools. We just got in a lot of the 1991s. We get in all the service manuals. How many have heard of the Stealth? There's the service manual. Laser Talon, this vehicle right here. This one happens to be engine, chassis, and body. I have another one up here that is electrical. A complete separate manual for electrical diagnosis. That's 1991. We get them all. Reference books. A604 Ultra Drive, electronic automatic transaxle. This is a new 4-speed computer-controlled transaxle. No bands, no governor, very little valve body. 4 solenoids control 4 clutch packs. Give you your upshift and downshift. What's it use? It uses throttle position, it uses other inputs to make that transmission function. Student reference books. I teach that transmission in our automatic transmissions class. We're up to date. We try to give you today's technology on today's vehicles. Everything else that would go to a dealer every month. Master Tech. Chrysler, Plymouth, Dodge. It's a technical tape with the accompanying booklet that goes along with the tape. We use those in class whenever possible. Video Tech is the Jeep Eagle version. This one's on a Jeep security alarm system. This one here is on the C²D data bus network, operation and diagnosis. Now what in the world is a C³ or a C²D data bus network? It's a sharing of information between the electronic engine controller, all right, our SMEC system, okay, our engine computer system, and a body computer. If they're sharing the same information from circuits and sensors, we have computers on board now for the A604 transmission, for the engine diagnostics, for the anti-lock brake systems, for the passive restraints, better known as airbags. All right. We have separate computers. They all talk to one another if they share sensors, and they share it through a data bus network. Very few wires between them. They share different wires. That's one of the technical tapes that came out for, I guess this one was March. February had part 1. We use that in class. We're going to be talking about body electronics in this class I have coming up for the summer term. And we'll be using this information. All right. What kind of time are we looking at here, you know? What time do you guys roll out of here? 10:25. Oh, good. Okay. What I'd like to do now is I would like to run a tape. This is a tape put together by Detroit. All right. It's at the Macomb County Community College, which is outside of Detroit. It was the first school to do this. It was the pilot school. Mercer County Community College was the second CAP program in the country. We're now one of 5. And we've been doing it now for 5 classes. You folks, if you choose to come in September, would be in our 6th group. So we've been doing it a while. We graduated 3 groups. I have my 4th group graduating as of the end of July. And the other group will be going into their 2nd year in September. So I usually have 1 2-year group and a 1st-year group. And again, we'll just run this tape and we'll answer any questions, comments you might have afterwards. Joe, you would like to say a couple words after the tape? Okay.
Perhaps the most exciting and competitive in the world, is the fast track. It's on the cutting edge of technology. It provides a challenging work environment, and it also creates unique opportunities. But a field this competitive requires dedicated, highly skilled people willing to step up to the challenges that the auto industry offers. The problem is, there's a shortage of qualified people in some very critical areas of the industry. One of these job areas is that of the dealership service technician. So, who and where are the people that will fill these critical jobs? Well, believe it or not, they're people just like you. They're people who know what they want out of life and are willing to go out and get it. They enjoy the challenges that life offers, and they're willing to do whatever is necessary to gain the knowledge and skills required to meet the rapid advances of technology head on. They enjoy sports, quality time with their family, time to themselves, other people, and of course, cars. You've heard it before. At Chrysler Corporation, we want to be the best. And we've made tremendous strides toward achieving that goal, mainly through the dedication and commitment of the people who design, build, sell, and service our products. People just like you. To be the best is our mission. And in our constant efforts to be the best in service to our customers, we've established the Chrysler Dealer Apprenticeship Program, known throughout the industry as the CAP. The apprenticeship program is providing a golden opportunity for men and women across the country just like yourself. An opportunity to continue your education at one of the few select colleges across the nation, and a guarantee of a job in a Chrysler dealership upon graduation. In addition, the cost of your education will be equally shared with you by a sponsoring Chrysler dealer. You pay half, and your sponsoring dealer pays half. Considering the cost of an education today, that's quite a deal. But that's only the beginning. You'll also be paid wages while you learn, and you'll receive a cash bonus when you complete the program. That's called putting your money where your mouth is. And at Chrysler Motors, that's exactly what we're doing.
I'm finishing my 8th month in Chrysler's apprenticeship program. It's been kind of tough, but I've really been happy with the program here at the college. I thought I knew a little bit about cars before I got here. There's a big difference between backyard mechanics and the real world. That's what I'm learning here. So far, I've learned to diagnose and repair brake system problems, align front ends and balance tires, deal with the different electrical problems, prep new cars for delivery, and rebuild engines and transmissions. It's been great. The stuff we're working on is the latest equipment in cars. None of this stuff is more than a year old.
But don't get the idea that the CAP program is a free ride. At Chrysler, being the best means accepting only the most qualified people into the apprenticeship program. In order to get into the program, you will have to pass a college entrance exam. You'll be required to successfully complete all of your courses in order to acquire an associate degree through the participating CAP college and qualify for an ASE certification. As part of your education, you'll be expected to work at your sponsoring dealership under the direction of a master technician during your internship. And you will be obligated to work for your sponsoring dealer for a period of 2 years following your graduation. trained instructors. On the very latest Chrysler equipment and vehicles, using Chrysler-developed materials. During your first few years in the program, you will alternate between periods of classroom instruction and periods of working at your sponsoring dealership. This alternating work-study schedule will continue throughout your course of instruction. Upon graduation, you'll receive an associate degree from the participating college and begin your full-time employment at your sponsoring dealership as a journeyman technician. So, the name of the game is commitment and hard work, but the rewards are worth the effort.
I was pretty nervous the first time I had to go to the dealership for my on-the-job training. I didn't know if I'd be able to work on a real customer's car all by myself, but I ended up doing okay. I guess I was a little slower than the guys who were journeyman technicians, and I couldn't handle everything that came in the door, but they didn't expect me to. But I didn't have any problems at all with any of the things that I'd learned to do in school. I couldn't believe I was actually working in a dealership and getting paid for it while I was learning.
The way I figure it, there isn't much that you can count on in the world today. But one thing for sure, cars are going to be around for a long time, and somebody's got to keep them running. I've always liked working on cars, but I never figured on being able to work for a big auto company dealership. It's been hard work, and I've still got a long way to go in the program, but I feel like I'm really working towards something. The teachers here at the college really know what they're talking about. They tell you up front what they expect you to learn, and then they spend the time teaching it to you. But it's not just cars and technical courses. You also have to take courses in English, math, social sciences, and things like that. They don't make it easy for you, but I figure it's worth it to study hard so I can have a good job when I graduate.
I just graduated from CAP, and now I'm working for my sponsoring dealer. I was guaranteed this job before I started the program, but I'll tell you, it wasn't easy getting here. I've never studied or worked as hard as I have in the last 2 years. I got into the program because I wanted a career that was challenging. I didn't want to spend all my time doing the same things day in and day out. The CAP program gave me what I want, the chance to work with my hands and my brains. I was a little worried if I'd chosen the right field when I got into CAP. I wasn't sure if I'd be accepted in an automotive technology program, but that's in the past now. I made it.
Now a service manager for
This is a pretty big dealership.
Chrysler
We sell a lot of cars,
dealership.
and as a service director, it's my job to make sure our customers are kept happy after the sale by providing them with the best possible service and maintenance. And that means top-notch technicians that I can count on. I don't have a problem finding people who claim to be technicians. We run an ad for help. They line up around the block to get a job here. The biggest problem we've got is finding people who really are technicians. People who know Chrysler cars and technology and can jump in and get the job done right the first time around. We're pretty heavily involved in the CAP program. We've had as many as 4 students working here at the same time. When you add up the cost of educating these people, the total is pretty high. We figure it's worth it because these CAP students study hard, they work hard, they show up on time, and they produce. We think of it as an investment in the future of the dealership. We like to continue growing, and a good service department is important to that growth.
The Chrysler Apprenticeship Program is providing the opportunity and the means for you to enter into a rewarding, challenging career in the automotive industry. As a student in the program, you'll receive the highest level of education available to help ensure your future success in your career with your sponsoring dealer. Through your on-the-job training, you will have the opportunity to work in a real dealership and be paid for your efforts. And when you graduate from your participating college, you'll have all the knowledge, skills, and experience necessary to begin your new career with confidence that you can perform to your dealer's expectations. Chrysler Motors is providing the opportunity. If you feel that you're qualified and are willing to step up to the challenges that the auto industry offers, then we'd like to hear from you. If you're interested in becoming a student in the Chrysler Apprenticeship Program, the nearest Chrysler Service Zone office can give you all the information you need to get started. You can get the phone number of the zone office from any Chrysler, Plymouth, or Dodge dealer.
was here not to sell you on anything today. I'm here today to sell you something. I'm here to sell you on yourselves today. Nothing else but yourselves. Can you succeed through a program like this? Like ours, yes. Can you succeed through other ones? Yes. Well, what's it take to make up your mind that you want to accomplish it? And I very rarely ever see anyone who has made the determination to complete something, I mean a true commitment, determination to complete it, not succeed. Does that mean they'll fly right through it the first time? No. They might find minor failures along the way. But do they come back and conquer it, accept the challenge and conquer it? If they're really committed to it, yes. I myself am a graduate of a community college, Pennsylvania. I went on to complete my 4-year degree at a 4-year college, and now work for Chrysler Corporation. Why did I go to community college? Number one, financially, that's what was capable for me to do. We didn't have programs like this back then. This was made it much easier to complete financially. And number two, I wasn't the top of my class. I chose community college because a couple colleges, major 4-year colleges, I didn't get accepted at when I applied the first time. So I took the route that was available to me, went to community college, proved to the 4-year colleges, I was capable of making it through a program. Same type of things available to you through the CAPS program. And it talked about several items in here. There's a major meeting coming up in the near future, advisory meeting, which will go into the national, where alterations to the program are going to be suggested, possibly put into effect. So you need to keep in touch with Mr. Bassini to see what the changes are. A lot of our students didn't like locking themselves in for a 2-year commitment after completion of the program. So certain things are going to possibly change. I don't know all the details, all the recommendations that are going to be made, but the program is being modified slightly from what you saw there. The main thing, whatever you might choose to do, I can mention to Fred earlier, mentioned the last group. This is our 2nd year here. This is several years I've been out talking to seniors at high schools, at both tech schools, about our program. We've been into it for 5 years now. The groups are much more mature. You have much bigger decisions. Times have changed. Just looking around, I can tell we have a much more mature group here than I had 4 years ago when I was out talking to high school. Times have changed. It's a faster lifestyle. You make more decisions. You're more independent. You can make the choice where you want to go, what you want to do, when you want to complete it. It's a matter of sticking to it, and you can do it. So keep an open mind today when you go through all of them. Yeah, you're spending your time here today. Don't waste your time here today. Go home with something out of it. If nothing else you go out, I hope you go home with today that whatever you make your mind up to do, you can do it. So just keep plugging at it, and thanks for your attention. I'll turn it back over to Fred for questions and more about the college program itself, how it works.
I'm the resident instructor for AC Delco in this northeast region, which spans from Caribou, Maine to Delaware, into Maryland, and from the coast all the way into PA. That's one of my duties. The other duties, I'm also a field engineer for AC Delco, and I also handle product liabilities, where somebody says, gee whiz, I put one of your parts on, it caused a failure and it hurt my car. Like put a spark plug in. And when he installed the spark plug, he took it out using a long extension, a ratchet with a swivel head socket, and the ratchet's about this long. You've seen them. And when he takes them out, he bitches about how tight the plugs were when the car was manufactured. Why do they make them so tight? And then when he installs them, he goes in and goes, drives the car down the road. It's a pickup. Puts a load in the back, drives it, bingo, wipes out a spark plug. Pulls out the plug because of an engine miss. And he sees, gee whiz, the electrode's missing. Yep, electrode's gone, finished. Where did it go? Oh, shit, I know. It blew a hole in the center of the piston. That little piece of metal fell off and put a hole this big in the center of the piston. Not at all. It's known as pre-ignition. Basically, when he put it heat into the head. And the tip glowed. And as it glowed, it fired the combustion chamber on TDC rather than spark. Because when we fire a combustion chamber, we fire 10 after top dead center. Things like that. AC Delco, wonderful division. The division for you people, for independents, for your instructors, for people that own gas stations and repair facilities. AC Delco is the parts aftermarket, or the sale of aftermarket parts to the industry. There's two basic divisions. SPO, Service Parts Operation, and then they split it. GM Parts, AC Delco. AC Delco is responsible in the area for about $280 billion worth of part sales a year. 280 billion, doesn't sound like much. However, if you rated them on the top 100 list of the largest corporations in the world, just this one tiny division in GM, we would be 37. Just that one little entity, and we're just a piece of scrap that gets pushed around. AC Delco is here for you in respect to training, support. We offer training center schedules that are published quarterly, and what we do with those schedules, we send them to our suppliers that supply the aftermarket, who sends them to you. If you ever chose to go into industry as an independent, working for your father in a gas station, or working for someone that you knew in a repair shop, rather than going to the dealer, this is where you go for training. Now, what's the purpose of that? How much does it cost? Training is free. We don't charge anything for training. We don't charge anything for our books or literature. We just want to get you educated. Education is a very critical part. You guys might laugh and smirk about education. That's fine. Because 20, 30 years ago, you didn't need to get educated to get in this business. Shit, you took the wrenches and went to work tomorrow. I'm an automotive mechanic. Try it now. I dare you. I dare you to try to use your skills without attending classes at the high school that you're coming from at a trade center. I would love it. I'd let you go on that car and let you fix something that I'd bug in there, and it'll take you a month. Not a month in respect to 30 days, but a month of Sundays. Don't underestimate education. You have in your hands the greatest possessions in life. Instructors that care about you, that are willing to take you here and get a feeling of what's in the outside world. You have instructors that didn't have to come here. There's schools in this area, right down the street, that are not here today. My son's enrolled in a program at Cherry Hill. They're not here today. Do they know it all? Don't ever feel you know everything in this business, but you never will. You will never in a million years. If you live to be 1,000, you will not know everything about that automobile right there. And as you get older and wiser, you'll realize when you're in your 40s, not how much you know, or how much you didn't know all these years. Holy shit, I didn't know that. I should have known that the first week out of school. You'll realize how much you don't know. That's why you have a division like AC Delco. AC Delco, no other corporation in the world offers training in the aftermarket like we do. Nobody. If you were to go on the outside presently and learn about a CCC system, or an EFI system, or a PFI system, I just mentioned 3 fuel injection systems and 1 carbureted system. Basic, $200 to $400 a day right now. And you pay for books. That's what it's going for on the outside. Now, we're not doing it because we love you. No, we care about you. And the reason we're doing it is because we want you to use AC Delco products. We also would like you, if you're working in an independent facility, that if we can train you how to operate and fix that GM car, when someone walks in the front door and asks you, what car do you recommend I buy? And you're savvy on that vehicle and you're confident in the repair of that vehicle, you're going to say, buy a GM car. That way I can continue to service you. I have a lot of my shops. A lot of guys that I've had here as students basically only specialize in GM cars. That's a shame. I didn't want to accomplish that, but some people feel that's the only avenue to go. Since I'm only the one supporting them, that's what we're going to do. We have a lot of other information. We have a computer circuit terminal. This was only given to the dealers. However, we came out with it and we sold it through Sun. That's why it's called a Modular Technicians Terminal. They market it, but it's our information. All our service bulletins for 1980 are in there. Wiring schematics are in there. Service skill publications, updates. Everything's on a CD that we plug in and send to each customer who purchases one every month and updates them right up to that day, just like the dealers have. That's only through GM. So we're trying to give everybody information. We're trying to give you information. You people have a decision to make in the near future. What are you going to do with your lives? Are you going to go into the automotive sciences? If you do come into the sciences of the automobile, the one area that I want you to be perfectly and understanding and confident and an expertise, and that's electricity and electronics. That's the area to go. That's the bucks. You always like bucks and the nice cars, that's the bucks right now. Lab scopes have become something of a repair tool used in automotives right now. Never before. Never. Oh, lab scope, are you kidding me? You can't watch Simpsons on that sucker? It's no good. Yeah, lab scope is part of diagnosing a vehicle at this point. Never has been before. A lot of people are really not ready for that. That's why a lot of places are just shutting down and going out of business. That gas station is now a coffee shop, isn't it? You've seen them. Absolutely. You've seen the repair shops just shut down, haven't you? The technology in the next 4 years is even going to be greater. Number one, by January of 1992, are you all aware that an automotive technician that services air conditioning has to be certified? That in January 92, there's legislation present in the Senate, and they're lobbying that if you're not certified on air conditioning, you will not be able to buy parts for an air conditioning system, not alone the Freon. That's where this business is going. Certification, licensing, and that's what you guys should do every night before you go to bed. Kneel down and thank God. Because once it becomes that way, name your ticket. You have a future that is bright as the sun on a clear morning in the east. You have a future that wasn't there for myself and that gentleman and that gentleman. When I went to school, there were no boat tech school. You learn the hard way. You have a future where you can become an instructor. Yeah, you're smirking now. Oh, shit, who wants to do that? Where you could have a job like mine. I was a mechanic. I was a shop steward. I was a foreman. I was a service manager. Then I said, I have to get smart. I got to go back to school. I went to Fairleigh Dickinson for automotive engineering. And I lucked out. While I was there teaching, going to school, I got a fellowship. When I got my fellowship, I had to start teaching at night, and I used to teach coefficients. That's the amount of drag that's on the front of that vehicle. How much horsepower does it take that car to go down the road at 45 miles an hour? Take a guess. Anybody? 7.5 horsepower. 15 horsepower for a vehicle that weighs in a category of 4,500 pounds. 15 horsepower. What did it take a car back in 1970? Those big garage door Plymouths or Chevys. Okay? That's coefficients, aerodynamics, drag, resistance, tire resistance, the brake resistance. Those are all things that have to be figured out before a car can be produced. 15 horsepower, 7.5 horsepower at 50. However, at 100 miles an hour, we need 70 horsepower. At 150 miles an hour, we need over 300 horsepower. At 190 miles an hour, we need almost 700 horsepower. What's holding the car back? One thing, air. That's right. Just one thing. Coefficients of drag. That was a complete Completely different field when we went into that. Not only are we going to design them, we have to design them in a way that they're sleek as possible. Where do you come into this picture? Education. You have ASEP programs that are supported in the colleges in your area. Community colleges where you can attain an associate's degree after 2 years. Be sponsored by an automotive dealership. You also have Lincoln Tech and Penco Tech. I don't really go crazy for them. You also have programs offered by Ford and Chrysler and Toyota. You also have Ferris State. Ferris State is a college in Michigan where not only do you learn the basics, but it's a 4-year Bachelor of Science degree in automotive technology. Unheard of. Who the hell gives you a 4-year degree in automotive sciences? They do. Not only do you go there and learn one thing, but you understand chassis design, building chassis, building engines, cores, shock peening, blueprinting, airflow, research. All of that is done in that school. Everything. From electronics to casting an engine block. How do you do it? Milling machines, boring bars, surface grinders, everything's there. It's an incredible institution. A lot of guys that are in my position have and attained their degrees at first. A lot of people. So these are avenues that are open to you. They weren't there 20 years ago, 30 years ago. You had to go to the school of hard knocks, learn it. And years ago they used to say, oh shit, you open up a book, look at a dummy. Can't even fix a car without opening up the book. Well, if you don't open up a book before you work on an automobile today, you might as well hang it up. If you don't have a book to look at, don't even attempt it. Because I'll tell you one thing. If I pulled 2 Suburbans in this room, and I told 5 of you gentlemen and ladies to take the body off of that chassis, I bet in 6 hours you'd have the body off the chassis. There wouldn't be a problem. Not one single problem. You'd love doing it. However, if I got some dealer technicians or independent technicians that haven't been trained, and I put a short in that Suburban and put it over here, you would find the same mess in about 6 hours. Why? Because they don't know how to read a schematic. Because they don't know how to locate wiring shorts. Shorts to ground, opens. Everything that flows through the damn wires they call juice. Ain't shit of juice in there. Juice comes in containers. Apple, tomato, grape, V8 does not flow in these electrical circuits. That's why it's so very important to get a grasp on electricity. Electricity is not measured in time. Nobody can tell you, take off that valve cover and change the gasket, I'll pay you 3/10 of an hour. That's 18 minutes. Fine. Make it a boot, takes it off, puts a new one on, bolts it in. I got a short in that car that you and myself haven't found in 2 weeks. Can you solve it? Oh yeah. 15, 20 minutes later, an hour later, you found the short. What's it worth? 3 hours. 4 hours. If you have your own facility, what's it worth? 150, 200 bucks. Whatever it's worth. This is something that doesn't have a monetary value on it. You know, a lot of times guys go to school, they come here, they lose a day's pay or 2 days' pay. This is what they feel. And the first thing they do is go back to the shop and raise their labor rates. That's the stupidest thing I've ever heard of. They go from $25 an hour to $35 an hour because they went to school 2 days. What's that? Why would you do that? Keep the value at the same, $25, but with your education, what's that going to do with the necessary time that you have to diagnose this problem? It's going to cut it down. You're going to find the problem sooner, and you'll find it more efficiently, and that is the compensation report. In the room here with us today, we have a 1991 Regal Grand Sport, 3.8-liter engine, which they call a 3800. It's much different than a regular 3800. I'm sorry, than a 3.8. A 3800 has a bow and shaft, has a fast start ignition system. In the 91, it doesn't use an EGR valve any longer. What we've done, we've increased the cam overlap on the cam. But you couldn't do that using a regular flat tapping lifter. You had to go to roller lifters. so you can change the ramp. What do I mean by the ramp? Basically, a cam looks like this. It has a ramp for the lift of the travel. You make the ramp too steep, or the top opening, the duration, too wide, the lifter cuts off the ramp. Cuts it. So you wipe out a cam. Rollers look like that, or like that. Look at the duration angle you have on this cam. Why? We'll just put a wheel on there. Go right over. No problem. So now we can quench the cylinders on the exhaust and intake, on the overlap. Quench them down, don't even need an EGR any longer. We also have a scanner hooked up to that car. That scanner is made by Electronics, which is a company out in the Silicon Valley of California. Basically what we do with that is we retrieve information from the computer. Whatever the ECM sees, we see. However, what's different about that?
But the computerized system, very, very easy to work on. One of the reasons it's easy to work on is the small microprocessor that is in this car is looking at all these sensors, and it's being reported on what we call a data stream. When these sensors go either too high or too low in voltage, or they show the incorrect on-off type signals, or perhaps a varying resistance reading, the computer will recognize that. It will turn on a little light on the dashboard and tell you, service the engine now, or soon. Okay? So that's real easy. You get a light turned on. We can use several devices. We can do it mechanically, or we can use a scanner or a computer to diagnose the computer system. Basically, what will happen when the light's on, if you do it mechanically, there's a little plug you would just jump across the two correct terminals, and the check engine light will now flash. You count the number of flashes. They would give you a code. You open up your diagnostic book, and you proceed through the diagnostic chart. Or you can interface a scan device to it, and you can actually read the same thing that the car is reading. And that's what we'd like to do today, to show you how to scan a car and how perhaps you would correct some problems. If everybody wants to kind of get up this end, we can look at the monitor, because what's going to come up here will come up on our TV screen also. Now, we have one small problem. It is a manual device. We need somebody to push some buttons. Would you like to volunteer? Okay.
Joe?
Now, we have a problem with the vehicle. It's in your dealership or your repair shop, or it could even be in your school. On the repair order is the complaint, so you do your basic diagnostics first, and also hopefully on the repair order is the serial number of the car, because if you'd like to use a device like this, you need to know a little bit about the serial number. You must know the 4th, 8th, and 10th digit. The 4th digit will tell you the body style. The 8th will tell you the engine, and the 10th will tell you the year. Okay? We've looked on our repair order, or better yet, we went over and we looked actually on the vehicle. And we discovered it is a 1991 vehicle. So just enter 91, please. Okay. Now, there's several ways we can continue. We can select a fuel system and answer a lot of questions, but the more questions you answer, the more chances of error. So the fastest, quickest way into this system is by our VIN code selection. So simply push 0. Okay. The 8th digit is X. X cursor is already blinking, so we'll tell it, yes, it is an X vehicle, or engine rather. Now, is it a 3.4 liter double overhead cam, more fuel injected, W car? Yes, it is. Is it automatic or manual? We would have to, well, we drove the car in actually. We know exactly what it is. This is automatic, so we push 1. Now, hopefully you have done preliminary diagnostics and you will not do another diagnostic circuit check. So we already did it. We'll just tell it, no, we don't want to do it because we have already done that. Now, we will select the data list, which is FO. Now we will read all the sensor inputs that are coming to the computer. Okay, the first one up is engine RPM. Obviously, the engine's not running, so there's no RPM signal. Now we're looking at the real engine RPM. The one below it, that's on the memory bank of the computer. The computer is saying, I want it to idle at this. So as the car warms up, I'm going to make this idle match that idle. If it does not do that, it will set a code, a check engine light, and a code for it. And we know we have an idle control error. Okay, now what could cause that? Most likely cause more likely we have a vacuum leak somewhere in the car, or we can just pretend the engine's been sick. It's been in our garage all night going coughing, and it's got a head cold. Now, what normally happens when you have a head cold? What's your nose do? Runs, right? Maybe the injectors are dripping. That would be another cause. So we'd use a little bit of common sense and say, what could influence my idle speed? Go to the next one. Say yes. Yes will scroll us through the data stream. Next one to come up, we're looking at the coolant temperature and the air temperature of the air coming into the engine. Okay. These two are used to calculate load, which would include timing and fuel delivery. There are certain things we'd like to do when the engine's cold, certain things we'd like to inhibit when the engine is cold, and we'll use this sensor to do it. It should always read something. The fastest way to check these two sensors is simply go outside, do not start the vehicle up as it's sit for several hours. They all should be the same as the outside ambient temperature. And if they are, you did a real quick correlation test and you got an idea that very possibly it does work. If you hit yes, we'll see the next one. Older cars that had vacuum advances to distributors, we had vacuum controlled power valves and carburetors, and we will continue to use vacuum as the main load sensor. The only difference is we're going to send it into a little device that will change it to an electrical signal so the computer can use it. And as vacuum varies, so should that. I've been looking for that. Down here, before we start the engine up, this one sensor does two jobs. It reads the barometric pressure. Now, that simply means the car wants to know, is it in Atlantic City or is it in Denver? What would be the difference? Anybody know who the first man to break the 4-minute mile was? Anybody jog or run? It was Roger Bannister. Okay.
As old as you are.
Yeah, okay, anyway, well, that's part of history anyway. But he ran a sub 4-minute mile, 3 minutes 59 and some odd amount of seconds. And I'll bet you he did it in Atlantic City. Because if he was in Denver, what do you think would happen to him?
That's out.
A lot longer, less oxygen, okay? Car's no different than a runner. If we have less oxygen, we're going to modify the fuel delivery and give it less fuel. If we have more oxygen, we're going to give it more fuel. We also modify the ignition timing at the same time. And we do that with that simple sensor on a kiosk. I think this car would run or start if we thought it was in Denver. Probably the fuel delivery would be so lean, and we know we have lots of oxygen in the Atlantic City area, we'd probably be too lean, we couldn't even start the vehicle. So that's pretty cool. Okay, go to the next one. Throttle positioning sensor and throttle angle. On the throttle shaft is a little sensor that will tell us how far the throttle is open. All the earlier cars, we only gave you voltage. Late model cars, we actually give you a percentage. If you saw 50%, what would you know about the throttle? Half open, sure, that's real easy, isn't it? And it will change as you open and close the throttle, and the computer will use that as an input for a load. Okay, go to the next one. Now we're looking at the oxygen sensor. Right now the vehicle is not running, and this voltage is being read off the read-only memory of the computer. The computer is saying to itself, when I see that voltage there, everything's perfect. I'll make no corrections to fuel delivery. If the voltage goes above it, it's running too rich. If it goes below it, it's running too lean, and I'll make all the necessary corrections. And pulse width would be the time that the injectors are on for. Okay, let's see. How can we use that? Oh, the engine's idling. Any load on the car? Very little. Be a real low number. If I was to accelerate the engine, the number should climb up. If you were to do that, you saw a low number, you snapped the throttle, it jumped up to a higher number, the engine didn't belt, backfire, belch, wheeze, hesitate, you'd say what? Hey, it probably worked. How about if a belch of fire came out of the manifold and blew the air cleaner off? Even though it said it did it here, somebody's lying to drive a problem. Go to the next one. Spark advance. Base timing of this engine is 5 degrees. The ECM will take that and add the proper amount of spark advance to arrive at the correct timing procedures. And it will vary with engine RPM and temperature. Okay, go to the next one. Integrated block learning. These are fuel controls inside of the computer. Okay, a good way to really get a basic understanding of this is, we have an old carbureted engine. We're sitting at a traffic light. The light changed. I want to move the vehicle. What do I need right away? Need some fuel. Okay? You'll now use the accelerator pump, the idle and the off idle circuit. That will supply enough fuel to launch the vehicle. When you get up a little bit of road speed, above a certain RPM or load condition, they will not supply enough fuel. We need to go to the main metering circuit of the carburetor. That's what that is. This is real short, and that's long-term fuel correction. And this guy here is pretty neat. Now, we do not have intelligence in the computer, but it will kind of learn how you drive your car. If you're the first one out from a traffic light, you're the leader of the pack, you're going to have your foot pretty heavy in the throttle. You're going to need a little more fuel. This guy will remember that. You'll be a little higher number. If you happen to get up early Sunday morning, go out, and that proverbial little old lady or man that has that 25-year-old car that still looks like brand new, that you only bring out of the garage on Sunday, and they drive real slow, and they can never understand why there's no traffic. It's all on the back of them, right? Okay. Their numbers will be down a little bit, and it will remember that. And it will remember how you drive. Go to the next one. Okay. Open or closed loop. This simply means, are we using the oxygen sensor or are we not using the oxygen sensor? We need the car warmed up, running for a period of time. We need the exhaust system heated up. We need the O2 sensor heated up to about 600 degrees. And then we will go into what we call closed loop, and we will use the information from the oxygen sensor to control fuel delivery. Block learn cell will be our cells associated with block learn. Okay, one thing to remember, if you scan a car and this comes up and you are idling, you better be in the zero cell, otherwise you're adding fuel. And if it is a higher number, that's your problem. Now, why are you adding fuel? As soon as you arrive at that conclusion, you probably repair the vehicle. Go to the next one. Okay, knock retard. This vehicle does have a device that will modify the ignition timing. Even though the computer says I went 30 degrees, if the engine is on detonation, the knock sensor will signal computer, and timing will now retard. That kind of saves pistons and things when you go up a steep hill under a very heavy load. Now, wait a minute now. Drivability complaint is poor fuel economy, loss of power. I'm driving down the road on a level road, not under any type of heavy acceleration, and I see numbers coming up on here. What's that tell me immediately? Timing is being retarded by the computer because it's getting a signal from this device when it shouldn't be getting it. Perhaps we have a spark plug wire laid over the device or something, and every time we fire a plug, we send a signal, and the ECM intercepts that as a knock signal. It could be that simple. Go to the next one. There are 3 little solenoids on here that open up a hole into the exhaust stream, and that's our EGR valves. We use what we call them digital now. They're electric. There's no more diaphragms on a lot of cars anymore. They're very, very reliable. They don't give problems like the earlier styles did. And as they turn on and off, or a combination of them, you can actually read. What are we using EGR valve for? Anybody know? I don't know what the instructor's telling me. Well, if I put a little bit of exhaust gas back into the cylinder, it's called an inert gas. It won't burn. There's no oxygen. Now I stole some room for oxygen, didn't I? Wouldn't that limit how much combustion took place in the cylinder? Gee, would that limit temperature? If I can keep the temperatures down around 2,500 degrees, I don't form any nitric oxide emissions. And then we comply with the federal law. That's the main reason we have an EGR valve, nitric oxide emissions. Give me the next one. Okay, idle air control. On the front part of the engine where it gets its air, the throttle shaft is closed. The throttle blade's actually closed, blocking it off. I need some air. We have a little electric motor that'll move a little pintle in and out, and it'll supply air. If I want to up the RPMs at idle, I'll simply move the motor a little bit and let a little more air in. If I want to slow it down, I'll move the motor again, and I'll cut off some of the air supply. Park neutral switch. There's a little switch to tell me whether I'm in park, neutral, drive. Could be my drivability problem. Very simple to check. Put the car in drive, it reports you're in drive or reverse. Put it back into park or neutral, it tells you park or neutral. Neat, huh? Real quick diagnostics. Next one. Miles per hour. A little electric generator on the transmission. It generates a little signal, and as you're rolling down the road, the ECM counts real fast. So it goes 1, 2, 3, 4, 5. This is, gee, that's 33 miles an hour. That's what it puts up on the odometer for it. Speedometer. Torque converter clutch. Naturally, it's off because we're not rolling down the road. When it's time for the computer to turn it on, that signal should go from off to on. As you feel a little bump as it engages. It tells you real fast whether it worked or not. Next one. Okay. Battery voltage. fuel pump voltage. Right now the engine isn't running, there's no sense having the fuel pump running, so the computer has it turned off. When the engine is running and the computer is receiving a reference or tact signal, it says, I'm going to turn the fuel pump on. This voltage should be the same as that. You could be looking at that, drive down the road, and the car would momentarily hesitate or slow down a little bit and pick up. If you saw that voltage disappear and then come back, what do you know immediately? Got a little problem in the fuel pump circuit, or perhaps in the circuit that supplies the voltage to the fuel pump. Real quick diagnosis. Next one. Cranking RPM, battery ignition voltage. Okay. A cardinal rule to remember about any fuel-injected car is, you give me a tact signal, reference signal, I will give you a squirt of fuel. No tacky, no running. So we have a device on the car that generates electrical signal. It's sent to a module. The module will send it to the computer, and the computer processes it. A very, very fast, accurate check on all the late model cars is simply crank the engine and see if you get a signal. Go. Did we see about 200 some RPM cranking? What do we immediately know about the signal now? It was there, it was sent to the computer, and the computer gave it to you. You have just checked 1/2 of the whole complete circuit. All you have to do now is realize, what does it do with that signal? Why? It gives us a squirt of fuel. That's the half you'll have to check now. Okay, give me the next one. Air conditioning request. Okay? Little switch up in the instrument panel. Turn on the air conditioner. The ECM should get a signal. When it gets that signal, it should command a relay to turn on and energize the air conditioner. Yes? On. Did it work? Suppose it said yes here and no there. You already checked half the circuit. Okay? Next one. There's a little sensor in the high side pressure system to tell us the pressure of the freon. Okay? Just think what would happen. Most air conditioners manufacture temperature here. Fan number 1 should come on this car at approximately 228 degrees. Did it? You could put something in front of the radiator to bring the temperature up. Don't walk away though. Stay by. Okay? So it did come on. At about 238 degrees, fan number 2 should come on. Did it? Quick way of checking out that circuit, the whole complete circuit. Power steering. Normal right now. There's a little switch in the high side system of the power steering unit. When you're in a parking maneuver and you turn the steering wheel, okay, that little pump's going to develop anywhere from 1,000 to 1,500 PSIs. That's going to put quite a load on a small engine. So we're simply going to tell the computer, hey, we're in a parking maneuver. The computer is going to bring the idle up 100 RPMs, and if the air conditioner is on, it'll probably shut it off too. A nice little deal. This is the charcoal canister purge solenoid. Okay, to control emissions, we store evaporating emissions in a canister, and every once in a while we'd like to purge it. So when the computer feels it is time to do that, it will turn this on, and it will take the fumes out of the charcoal canister, ready for next time when storage is needed. We generally purge a car when it's warmed up, under a load going down the road, because at that point in time we could tolerate a little richer mixture. Very seldom will we ever do it at idle. If it does it at idle, you probably found a problem with the car. Okay, next one. Okay. Shift solenoid A and B. Inside this transmission, it is electronically controlled. There are a couple solenoids in there that the ECM will turn on and turn off to control the shift points of the transmission. Normal state right now with the engine running, they'd both be on. You have to notice one's off. Halfway there, you got half your problem. Go to the next one. Okay. This would be the equivalent of a first gear switch and a fourth gear switch. We can tell what gear we're in. We can tell, the computer can tell. Next one, they're used to turn on the shift points and the converter clutch. Okay. Prom ID. Every computer might work in someone else's engine. The only thing is, we need a little chip for directions. How do I want the engine to perform? That's done with a program chip called a PROM or a MEMCAL pack. Everyone has their own ID number. Last week this car was into a dealership with a drivability problem. There was a service bulletin saying, update the PROM and make the car run better. So an updated PROM was put in it. If you have the vehicle now with a drivability problem, perhaps the wrong chip was put in it. Every chip has an ID number, and you can scan it. Yes, they are. There's a 2411 in this one right now. If If your service bulletin or your diagnostic chart says that's the one supposed to be in here, now you know it has the correct chip. You look somewhere else for your problem. Okay, go to the next one. Oh, there is no more. That was real quick. We got through the data stream. The only thing you'll find difficult is, what is the data stream supposed to be? Well, all our charts give you these particular readings. After you've worked on vehicles for quite a while, you get real used to it and you know exactly about where, if it says a volt and a half, if you're somewhere in that range, you'd say, well, that's probably normal. Okay, so this is not a big deal looking at the data stream. The computer's looking at it constantly. If it goes out of a certain window or range, okay, the computer will turn on the light. There's only one little problem with that. It has to go out of range for a brief period of time. 2, 3, 4 seconds under road speed cruising down the road. The problem with these vehicles in repairing them is intermittent. No code stored. In other words, I'm driving down the street and the car went, what caused that? Wait a minute, I'll drive it for about an hour. It did it again. Once an hour it does it. I bring it back into my service area and I'm looking at the engine and guess how it works? Works good. It's intermittent. Won't store code. How are you going to fix a car like that? Pull another car up alongside and start swapping parts? Sure, you could do that, except how do you know the parts you're putting on it are any good? How do you know they're exactly for that car? Okay? The way we recommend you fix an intermittent problem is use the same type scanner. This scanner also has capabilities of taking what we call a snapshots of the data stream. We're going to turn it into a camera, and while the car is running down the road, we're going to capture the data streams, and then we're going to take another look at them. If they're not normal, they must be what? Bad. Okay, hit the exit key now. Okay, we're going to let the data stream scroll. Holy cow, look at that. Snapshot. Hit 3. Okay, snapshot options. Any code, single code, or manual trigger. Okay? Any code or single code. Why are you out driving it if it's set of code? We'd like to take a snapshot on a manual trigger. Okay? Okay? Hit F2. Okay, now program for a manual trigger. You can hit enter, exit, or F9. Don't do it yet. Little W means we're waiting. We'll start the vehicle up, Mr. Tucker. Okay, the vehicle's now running. So we're driving down the road, and all of a sudden we're going to hit that magic intermittent. The engine's going to go, When it goes that, I'd like you to push the enter key. Ready? Listen to the engine. Yeah. Little T means trigger point. When a little zero appears, snapshots all over. Okay? Now, what we'd like to do is hit number 4. That will take us 40 frames before the trigger, and we'll have 39 frames after the trigger. Just simply push the up arrow and hold it down. We'll now scroll through the data stream. Okay, we're looking at engine RPM. We heard the engine cut out just a little bit, so we expect to see a little drop. It shouldn't go to 0, and it shouldn't go to 5, 6, 7, 8, 10,000. It should go to something, though. Okay, that guy looked pretty good there. Okay, hit the yes key again. Okay, now we're going to look at coolant and manifold air. Hit the down arrow and go back the other way. Okay, keep your eye on it now. You see anything? Look pretty good? Hit the yes key again now. Okay, now we're going to look at the map. Hit the down arrow. Excuse me, up arrow. Start hitting it one increment at a time. Push, push, drop it 1 frame at a time. Keep going, keep going, keep going, keep going. Oh, what happened right there? Stop. What happened? Map sensor signal went away. Hit the arrow one more time. Up. Look at that, it's back again. Hit the down arrow again. Okay, we're now on our bad data stream frame. Okay, we don't know right now whether that's the cause or something affected. So let's check real fast. Hit the FO key. Oh, there's a little asterisk here. We lock that. We'll stay on the same frame and we'll make the bottom move and we'll see if anything on the bottom disappears. So hit yes, 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 yes. That TPS is there. Throttle angle, oxygen sensor is still there. Pulse width, advance is still there. We'll simply scroll through on the bad data stream and see if something else disappears. And then we'll just reason out, would one do the other? Okay, so we're pretty sure right now it was the map sensor circuit only. This by no means we need just the sensor itself. Map sensor. We have a problem in the map sensor circuit. That would be the computer, the wires, the wire terminals, and the sensor itself, and engine, vacuum, and a vacuum line. So somewhere in that area, we do have a problem. Cannot discount the vacuum line just by seeing it going to zero. All right, now, we're pretty sure we got a problem in the map sensor circuit. Let's just prove how difficult this would have been to fix without a device like that. Hit the exit key. Hit it again. Hit 2 for a trouble code. Let's see what code that's. It should have given me a code 33. What code do I have? No code. Why not? Didn't meet the criteria for time. But it sure gave you a problem. The ECM knew right away, didn't it? And it said, ouch. I think I'll keep my eye on that circuit and see what happens, but it went away. So quit looking at it. All right? Now, most dealerships, technicians work on what they call flat rate. This job pays 1 hour. You're on your first hour, second day. How much you going to make? Without specialized equipment like that, these newer high technology cars are very, very difficult to service. But how long did it take us to find it? Just think if you really had a lot of training in this area, you knew exactly what you were looking for, how fast you could find something like that.